Welcome to Understand. This is Jordan over at SciTools. Today we're looking at spaghetti graphs and why they're way more useful than they look. Okay, look at this one. At first glance, it looks like a total mess, right? Just a pile of spaghetti. And that's exactly what one of our engineers, Natasha, thought when she first saw these graphs. She was completely skeptical that something this chaotic looking could actually be useful. Turns out, after digging into them, not only did she become a total convert, but she also built a plugin that uses the same style of graph to help you understand what's really going on inside of a class or a file. Let me show you how it works. So what we have here is the file dependencies graph in Understand, showing the CMake source code. Every node is a file, and every edge is a dependency. And the key insight is this: even though it looks chaotic, there's natural clustering happening. Groups of files that work closely together bunch up visually. A big tangled ball, that's a problem area. Distinct clusters, that's well-organized code. You can spot this stuff at a glance once you know what to look for. So Natasha took that same idea that we have in this graph here and applied it to the inside of a class, functions and objects instead of files. So let's look at an example of her custom plugin. Here we have the calls and called by graph for the class CMFindPackage command with the internal with objects variant selected. Here functions show up as squares, objects as circles, same convention you'll see in other Understand graphs. And for functions, size is based on lines of code, so longer functions jump out at you. Color is scaled by cyclomatic complexity, so the more complex, the warmer the color usually. For objects, size reflects how frequently they're accessed, and color shows how often they change, so a constant stays cool, but a variable that's getting modified all over the place lights up. Edges follow the same color coding as the object references graph, so blue for calls and uses, green for sets, and orange for modifications. So let's see what this actually reveals. If we open up the graph for one of our other classes, CMTarget, here we have a fairly large class. It's about 1900 lines. And as you can see, there's two kind of distinct clusters here, roughly equal in size. That's a signal for us. So this class might be doing two loosely connected jobs that could be split apart potentially. What's interesting here is that the right cluster is centered around a function, getPolicyStatus. It's small, it's not complex, but it's nearly central to how this half of the class operates. And then over on the left, everything is a bit more scattered with several larger, more complex functions interacting. So just from this one graph, you've got a roadmap. You have two clusters, one obviously a bit cleaner, and a potential refactoring opportunity here. Next, let's take a look at a different class, CMGlobalGenerator. This one is over 3,300 lines. Bigger class, bit busier of a graph. So as you can see, we have this big blue square here in the middle. This is a function called enable language. Large and complex, clearly important. But look at all the green edges on the left of it. They're all converging on the constructor, which is CMGlobalGenerator. So nearly every change to the class's data flows through this one function. If you needed to get up to speed on this class, you'd want to start with those two functions and then work outward from there. So remember, this plugin is called Calls and Called by Internal with Objects, and it's available in our plugins repository. Just go to the plugin manager by going to Tools, Plugin Manager, going into Graphs and Charts, and then make sure this Calls and Called by Internal with Objects is selected, and then just close. From there, it'll show up as a variant of the calls and called by graph for classes and files. So let's say we're looking at CM System Tools. This is a class. Then we just go to the graphical views, called and called by. And then here it defaults to the butterfly variant. But right up here, you can change the variant to internal with objects. And now you have the graph. So I encourage you to try it on your own code base and see what falls out. Is it clean clusters or is it a plate of spaghetti? Drop a comment and let us know what you find. To learn more about dependencies, plugins, or anything else in Understand, visit support.scitools.com.